One small step for man, one giant leap for mankind.
For more than 50 years, humanity has been tethered to low Earth orbit. But the era of staying close to home is over. On April 1st, 2026, 4 astronauts strapped into one of the most powerful rockets currently flying to rewrite the history books. This isn't just a joyride around the moon. It's the ultimate high-stakes shakedown cruise to prove we can survive in deep space. To get back to the moon, you need serious firepower. Artemis II launched from the historic Launch Complex 39B at NASA's Kennedy Space Center, the very same ground that hosted Apollo and the Space Shuttle. The vehicle of choice is the Space Launch System, or SLS, a 98-meter-tall behemoth generating 8.8 million pounds of thrust.
Booster ignition and liftoff. The crew of Artemis II now bound for the moon. Humanity's next great voyage begins.
Riding atop this rocket in the Orion spacecraft is a crew of 4 trailblazers: NASA Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Canadian Space Agency mission specialist Jeremy Hansen. Their primary purpose? A rigorous 10-day test flight. Artemis II is the very first crewed mission of the Orion spacecraft. Before NASA can put boots on the lunar surface or send humans to Mars, this crew must push Orion's life support, communication, and navigation systems to their absolute limits. Getting to the moon isn't a straight line. It's a masterpiece of orbital mechanics. Once in space, the spacecraft's path is defined by 2 key terms: perigee and apogee. In any elliptical orbit around Earth, the perigee is where the spacecraft is closest to the planet. The apogee is where it is farthest away. Rather than shooting straight for the moon, Artemis II first entered a high Earth orbit. This raised their apogee to tens of thousands of miles, allowing the crew to test critical systems in the harsh radiation of deep space while keeping their perigee low enough to guarantee a safe, rapid return to Earth if anything went wrong. Once cleared, the crew fired their engines for the trans-lunar injection. But unlike the Apollo landings, Artemis II doesn't stop and orbit the moon. Instead, it utilizes what's known as a free return trajectory. This is an elegant, gravity-powered slingshot. Orion harnesses the moon's gravitational pull to bend its path and naturally hurl it back toward Earth. If the main engines fail, physics itself brings the crew back. Because of this wide loop, the Artemis II crew will break the Apollo 13 record for the farthest distance humans have ever traveled from Earth. The mission concludes on April 10th, 2026, hitting Earth's atmosphere at a blistering 40,000 kilometers per hour, facing temperatures half as hot as the surface of the Sun before deploying parachutes and splashing down safely in the Pacific Ocean. Artemis II is more than a single mission. It is the bridge between our history and our future in the stars.